The question I get more than almost any other is some version of this. Should I fine-tune a model for my use case? And I understand why. The phrase sounds serious and technical and like the kind of thing serious AI practitioners do. But after watching a lot of people go down that road, including some people who genuinely did not need to, my honest answer almost every single time is no, not yet, maybe not ever. And in this video, I want to explain exactly why I feel that way, what the real difference between prompting and fine-tuning is, when each one actually makes sense, and where most people land in the middle without realizing it. Because the decision sounds complicated, but the honest framework is pretty simple once you strip the hype out, what prompting actually is. Let me start with the basics, because I think a lot of the confusion comes from fuzzy definitions. Prompting is what you are doing when you write instructions to a model before or during a conversation. It is the system prompt that tells the model what role to play, what format to follow, what to avoid. It is the examples you paste in to show the model how you want something done. It is the context you feed in so the model knows what it is working with. The key thing to understand is that prompting changes nothing about the model itself. The model's weights, the billions of numbers that define how it thinks, are completely untouched. You are just talking to it differently at runtime. The model forgets all of that the moment the conversation ends. Next time you talk to it, you start fresh, or you set the same instructions again. Prompting is fast and cheap. You write something, you test it, you see what comes out, you adjust, and you go again. The whole cycle can take minutes. There is no training step, no dataset, no waiting for a job to finish. You just iterate in real time. That speed is not a consolation prize. It is genuinely one of the most powerful things about working with modern language models. The cost of being wrong is almost nothing, so you can be wrong 100 times before you find what works. What fine-tuning actually is. Fine-tuning is something fundamentally different. When you fine-tune a model, you are actually changing the model's weights. You take a pre-trained base model, the thing that has already learned from enormous amounts of text, and you run additional training on a dataset you provide. Your examples push the model's internal parameters in a direction that bakes your specific patterns into the model itself. After fine-tuning, the model does not need to be told those patterns anymore. They are in there. It will produce output shaped by your training data without you spelling it out every time. That sounds powerful, and it is, when the situation calls for it. But there is a lot of machinery involved. You need a dataset, usually hundreds of carefully formatted examples at minimum, and often many more for good results. You need to run a training job, which takes time and costs money based on how much compute you use. And here is the part people often miss. When the provider releases a new base model that is better than the one you trained on, your fine-tuned model is now behind. You have to redo the whole thing on the new base if you want the improvement. Your dataset becomes a recurring maintenance cost, not a one-time investment. That is not a reason to never fine-tune. It is just the true price of admission, and you should know it before you start. The real cost compared, if you put the two side by side, the gap in overhead is pretty stark. Prompting costs you time to write and refine instructions. Iteration is free. You can test on live data, change something, and retest in the same afternoon. Fine-tuning costs you a dataset that has to be built, cleaned, and labeled. It costs you the training compute, which is metered and scales with how much data you have and how big the model is. It costs you the ongoing work of maintaining that dataset and retraining when the base model changes. Prompting also has limits. You cannot stuff infinite context into a prompt. At some point, the model's attention is spread thin, or the instructions get too complicated to follow reliably, or the latency of a giant context window becomes a real problem. Fine-tuning can address some of that by baking behaviors in so the model does not need to be reminded. But the threshold where those fine-tuning benefits outweigh the overhead is a lot higher than most people think when they first start asking the question, when prompting is enough. Here is the honest truth. For most of what people are trying to do, a well-written prompt is completely enough. If you have a task you can describe in words, prompting can handle it. If your task changes sometimes, prompting lets you change the instructions without touching anything else. If you are exploring what you even want the model to do, prompting lets you experiment fast without a dataset. One-off tasks are the obvious case. You need to summarize a document, classify some data, draft a message in a certain tone. You write the instructions, you test it, it works, or you tweak it. There is no universe where you should be building a training dataset for that. But even recurring tasks often stay in prompting territory for a long time. If you can write a clear system prompt that produces the output you want, and the model follows it reliably, you are done. The output quality from a well-crafted prompt on a modern frontier model is genuinely high. Most people are not hitting the ceiling of what prompting can do before they start wondering if they should fine-tune. If your current prompts are getting the job done, the answer is to keep using them, not to invest in a training pipeline you do not need. When fine-tuning earns it, so when does fine-tuning actually make sense? In my experience, there are a few situations where it genuinely earns its cost. The clearest case is a narrow, repeated task at high volume, where consistent quality matters and you are paying attention to latency or cost. If you are running the same classification or extraction or generation task millions of times, the economics of a smaller fine-tuned model start to look different than a big frontier model with a long prompt. Fine-tuning lets you use a smaller, faster, cheaper model and still get the behavior you want, because the training baked it in. That is a real advantage. Another case is strict format requirements that are genuinely hard to prompt for. If your output absolutely has to be in a specific schema, with specific fields, in a specific order, every single time without fail, fine-tuning can make that more reliable than any prompt. And the third case is consistent tone or style across a high volume of content. If you have a very specific voice, a very specific way of structuring responses, and your prompt alone is not holding it reliably at scale, fine-tuning can stabilize that. But notice the common thread. All of these cases involve scale, repetition, and a very specific, narrow task. They are not about making a general-purpose assistant smarter. Fine-tuning does not add knowledge, it adjusts behavior. If you are trying to make a model smarter or more knowledgeable about your domain, fine-tuning is not the right tool. That is a different problem. The middle ground most people skip. There is a whole band of solutions between basic prompting and full fine-tuning that a surprising number of people jump right over. The first is few-shot prompting. Instead of just telling a model what you want, you show it. You include 2 or 3 or 5 examples of the input you would give and the exact output you want back. For a lot of tasks, this closes the gap between a mediocre prompt and a great one. The model is looking at the pattern directly. It does not have to infer it from a description. Few-shot examples can be included in the same prompt as your instructions. They cost nothing to add beyond a little context length, and they update as easily as editing a text file. If you are struggling with a task and you have not tried few-shot examples yet, try them before you consider anything more expensive. The second is retrieval augmented generation, which is a mouthful but a simple concept. Instead of baking facts into the model through training, you look them up at runtime and include them in the prompt. If your use case involves a model knowing specific facts about your product, your company, your documents, retrieval is almost always the better approach than fine-tuning. The facts stay accurate, they update without retraining, and the model can cite what it pulled. Fine-tuning is a genuinely poor way to inject factual knowledge. It tends to hallucinate in unpredictable ways around the facts you trained in. Retrieval is more reliable for that job by a significant margin. Why most people reach too early? When I watch people decide to fine-tune prematurely, there is usually a pattern. They have a task that is not working well with a basic prompt. Instead of investing another hour or 2 in improving the prompt, adding examples, or restructuring the instructions, they conclude that the problem is the model and that training will fix it. Sometimes that is true, but much more often the problem is a mediocre prompt, and the solution is a better prompt. Fine-tuning on top of a bad prompt will give you a fine-tuned model that reliably produces the same mediocre output, just more consistently. That is not an improvement you wanted. The diagnostic question I would ask before anyone starts a fine-tuning project is this: have you really maxed out what prompting can do? Have you tried a clear, detailed system prompt? Have you added a few well-chosen examples? Have you tried breaking the task into smaller steps? If the answer to any of those is no, you have not hit the ceiling yet. Spend a day on the prompt before you spend a week on a dataset. The returns from prompt engineering on a modern model are often much larger than people expect before they have really tried. But fine-tuning cannot do. It is worth being explicit about this because there are some things people expect from fine-tuning that it simply cannot deliver. Fine-tuning does not make a model smarter. It does not expand what the model knows about the world. It does not give the model new reasoning capabilities. The base model's fundamental intelligence and knowledge cutoff are set. You are adjusting style and behavior, not capability. Fine-tuning also does not fix hallucination in any deep way. If the base model tends to confabulate facts, your fine-tuned version will too, just shaped around your training data. If anything, fine-tuning can introduce new failure modes, where the model over-applies the patterns from your training set in situations where they do not belong. You can reduce certain failure modes, but you cannot eliminate the underlying tendencies of the base model just by training on a few hundred examples. Knowing what fine-tuning cannot do is just as important as knowing what it can. The honest framework. So here is how I actually think about the decision. You start with prompting. You write a clear, specific system prompt. You add examples. You break hard tasks into steps. You test it and refine it. If after a genuine effort the prompt is not getting you there, you ask why. Is the problem that the model does not know some specific facts? Use retrieval, not fine-tuning. Is the problem that the output format is inconsistent? Try structured output constraints first. Is the problem that the tone wanders? Add more style examples to the prompt. If after all of that you still have a real problem, and you are operating at the scale where the training overhead is justified by the savings in cost or latency or consistency, then fine-tuning is on the table. But by the time you have worked through that sequence, a lot of people find the problem was solved somewhere earlier than they expected. Fine-tuning is not a shortcut to a better result. It is a specific tool for a specific situation, and the situation has to genuinely call for it. Start with prompting, always. The honest take is this. Almost everyone asking whether they should fine-tune should spend more time on their prompt first. Not because fine-tuning is bad, it is genuinely powerful when the situation fits, but because a good prompt is free, instant, and reversible, and most situations fit it just fine. The teams I have seen get the best results from AI are not the ones who jumped to fine-tuning fastest. They are the ones who got very good at prompting first, used retrieval to handle facts, added few short examples wherever they helped, and only reached for training when they hit a real, documented ceiling that could not be cleared any other way. That sequence is not cautious or timid. It is just the efficient path. And if you eventually do need to fine-tune, your dataset and the evaluation work you do will be much better because you deeply understand the task from all the prompt work you did before it. If any of this helped you think more clearly about the difference, or if you have been wrestling with this decision in your own work, subscribe and follow along. Thanks for watching, and I will see you in the next one.